Let's imagine for a second you're an architect, but you're not designing buildings, you're designing data systems. And your blueprint, it's not paper and ink, it's a diagram. Now, when that system gets complex, you need a more advanced blueprint. And that's exactly what an Enhanced Entity Relationship Diagram, or EERD, is. It's your guide for turning a complex idea into a powerful, logical database. So you've got your basic database plan sketched out. But then, reality hits. Your employee entity isn't just one simple thing, is it? Nope. You've got salaried staff, you've got hourly workers, maybe you even have consultants. They all share some info, like a name and an ID, but not all of it. So how in the world do you show these specific categories without making a total mess? A standard ERD starts to really struggle with this. And that's where the EARD swoops in to save the day. It is enhanced for a reason. It gives us the exact tools we need to handle this kind of situation, using these really powerful concepts called superclasses and subclasses, or as I like to call them, parents and children. This is the pro-level tool for modeling the messy, nuanced details of the real world.
All right, so here's the game plan. First, we're going to talk about why we need to go beyond the basics. Then, we'll decode the symbols. Think of it as your architect's toolbox. After that, we'll dive into the 2 critical questions that drive all the logic. Then, I'll give you a 5-step blueprint for drawing any ERD. And finally, we'll put it all together with a real-world example. Sound good? Let's do it.
Okay, so first things first. Why do we even need to enhance the diagram? Well, it's simple. The real world is chock full of categories and subcategories. We need a way to model all that complexity, and the 2 key ideas for doing that are specialization and generalization.
Think of specialization as a top-down approach. You start with a big, broad category, like employee, and you realize, hey, this isn't specific enough. So you break it down into more precise roles, like secretary or engineer. Generalization is just the flip side. It's bottom-up. You notice you've got these separate things, like a car and a truck, that actually share a lot of the same attributes. So you group them together under a general vehicle parent. It just makes your model so much cleaner.
Every great architect knows their tools inside and out. For us, those tools are the symbols we use to draw the blueprint. You've got to know what they mean. It's non-negotiable. So, let's open up the toolbox. First up, the most fundamental building block, the rectangle. This is just an entity. But in an ERD, we've got a clear hierarchy. The rectangle on top, that's our supertype, the parent entity. And the ones down below, those are the subtypes, the children. Now, what you put inside these boxes is absolutely crucial. The supertype, our parent, holds all the stuff they have in common. You know, the shared attributes like name, ID number, that kind of thing. And listen up, this is important. The primary key always lives in the parent. Always. The subtypes, the children, they only hold the attributes that are unique to them. A secretary might have typing speed, but an engineer probably doesn't. We call this attribute inheritance. Basically, the kid automatically gets all the stuff the parent has.
Next, we've got the circle. This little guy is the control center. It's the traffic cop. It's the branching point that connects the parent to its children. And as we're about to see, what you put inside this circle defines the entire logic of your data structure.
And finally, we have the lines. Now, these are not just for connecting the dots. No. The way we draw the line between the parent and that circle tells us something super important. Is this relationship mandatory, or is it optional? A single versus a double line, it's a huge deal. Okay, this brings us to the absolute heart of the ERD. This is where we put our architect's hat on and make the big design calls. It all boils down to answering 2 critical questions that will define the logic of your entire blueprint. And remember, these aren't just drawing conventions. They are direct translations of business rules. If you mess this up, your diagram isn't just wrong. The whole system you build from it will be wrong. The first question you have to ask yourself is about exclusivity. Is it disjoint or is it overlap? This is the rule you mark inside the circle. If you choose disjoint, you put a D in there. That means an instance of the parent can only be one of the children. It's an either-or situation. If you choose overlap, you pop an O in there, which means an instance can actually be a member of multiple child types at the very same time. Here's a perfect way to see the difference. On the left, with the D for disjoint, an employee can be staff or faculty, but the system rules say they can never ever be both. But on the right, with the O for overlap, the rules are totally different. In this system, a person can be on staff and also be a student at the same time. Which one you choose depends completely on the business rules you're modeling. All right, on to critical question number 2. This one is about participation.
Is it total or is it partial? This rule is all about that line between the parent and the circle. A double line means total specialization. That's a mandatory rule. Every single instance of the parent must be categorized into at least one of the child types. No exceptions. A single line means partial specialization. That's optional. An instance can just hang out as a generic parent without belonging to any specific child type at all.
Let's look at this visually. The patient diagram on the left has that double line. What does that mean? It means every single patient in the database has to be classified as either an outpatient or a resident patient. There's no such thing as just a patient. But the vehicle diagram on the right has a single line. This means a vehicle could be a car, or it could be a truck, or it could be something else just listed as a generic vehicle without a specific subtype. Again, it all comes down to the rules of the system you're building.
Okay, you know the concepts, you know the symbols. Now it's time to put pen to paper or, mouse to screen. Here is your clear 5-step blueprint for building a perfect ERD every single time.
So let's walk through it. Step 1. Figure out your approach. Are you starting big and getting specific? That's specialization. Or are you finding common ground between smaller things? That's generalization. Step 2. Draw your parent supertype. That box gets all the shared stuff and, yep, the primary key. Step 3. Draw your child subtypes down below with only their unique attributes. Step 4. This is the logic center. You add the circle and the lines to set those constraints we just talked about. And finally, step 5, make the final connections to link the whole thing together.
I really want to hammer this point home. Step 4 is the brain of this whole operation. This is the moment where you have to stop and ask yourself those two critical questions. Is it disjoint or overlap? And is it total or partial? Your answers determine exactly how you draw that circle and those lines, embedding the business logic right into the blueprint. Theory is great, but seeing this whole shebang in action is so much better. Let's walk through a practical example and see how all these symbols and rules come together to tell a crystal clear story about data.
So here's that hospital patient system we glanced at earlier. We've got patient as the supertype, or parent, with outpatient and resident patient as the subtypes, or children. The real power here is that we can read the business rules just by looking at the symbols. Let's decode this blueprint together.
First, look at that double line coming down from patient. That's total specialization. The rule is screaming at you. You cannot be in the system as just a patient. You must be either an outpatient or a resident patient. Second, see the D in the circle? That's the disjoint rule. It tells us a patient can be an outpatient or a resident patient, but never both at the same time. And finally, check out that is assigned relationship. See how it only connects to resident patient? That tells us that only residents get assigned a bed. Outpatients don't.
And just like that, with a few simple symbols, we've laid out a pretty complex set of business rules without writing a single sentence of text. That is the power of a well-designed ERD. It's a universal language for data architects that leaves zero room for confusion. It's a perfect blueprint. So at the end of the day, you now have the tools and the methodology to move beyond simple diagrams and start designing some really sophisticated real-world data systems. You have the blueprint. So the only question left is, what complex systems are you going to go out and design?